Hello and welcome to my new video which is based on the Fourier series and in that even and odd functions. So what are odd and even functions? Let us discuss about them. Let us suppose you have a function x square. So for it, if you have to find out the value of minus x, that means minus x square, that means x square. So if minus x value of function for value minus x is equals to the same function, then it is called even. Alright? And let us suppose if it is x cube, then the value of minus of fx is minus fx, like this. So then we called it as odd. Now if you have to evaluate Fourier series or expand Fourier series for even and odd function, then what you do? You have to remember some tips like even and even. On multiplication brings out an even number. Odd, an odd function brings out even. But odd one out, that means even and odd and even, multiplication of them gives odd. Okay? Because let's take an example. Even, let us suppose x square, this is x4, x6, which is even. Let us take odd, x cube, base same power add, that means even. Let us take this odd and even and odd. It will form x raised to power 5, which is odd. Okay? So what type of function you have? On the basis of that, if it is even and odd, there are different formulas for the Fourier expansion. What are they? Let us see. As we studied earlier, that Euler's formula is fx is equals to a0 by 2 sigma n 0 to infinity an cos nx and bn sin nx, where a0 is find out by whatever your limit is, fx dx. Your an is 1 by pi limit fx cos nx, and your bn is 1 by pi limit fx sin nx. Isn't it? Yeah, of course. So now what you have to do, you have to, let us suppose your case 1, you have your function as even. So remember two things. If you have even function, then the limit minus L to L, same to same, minus, brings out to be twice of 0 to pi, half range, fx. Okay, and if it is odd, if fx is odd, then it comes out to be 0. You can calculate it. If you describe the whole process of integration, then it comes out to be 0. Okay. Now listen, your fx is even, then what will be the formula of a0? a0 becomes 2 by pi, because twice occurs here if we take the limit from 0 to pi. Okay. Here you can see if your fx is even, remember this thing, your cos function is even function, whereas your sine function is odd. So it is, because as you know, cos of minus x is plus cos x. That's why I'm telling you that it is even, whereas sine of minus comes out to be minus, that means minus of function, so it is odd. This function, according to our assumption, is even. Cos is even by the formula of that. So even and even, product comes out to be even. That's why it also becomes twice. And on taking half series, half range, okay. Then fx is even according to our assumption, whereas sine, as we read here, it is odd. Okay. So multiplication brings out to be an odd number, odd function. That's why Bn becomes 0. Okay. Now let us take another case when fx is odd. Remember, for Fourier expansion, you have to do the whole procedure. Like you have to find out the a naught, an, bn, then you have to put all these values into your Euler's formula for fx. But now, if you have to study about even and odd functions, and you find out that this particular function is even or odd, if it is even, then you have to only find out the value of a naught and an and just substitute into this formula. There is no need to find out the value of bn, okay? Whereas, if you take another case where your fx is odd, so listen, your a naught is, again I'm writing it, minus pi to pi fx dx. Your an is 1 by pi fx cos nx, and your bn is 1 by pi minus pi to pi fx sin nx. Okay, you know it. Now your fx is odd, and for odd it will become 0. It will become 0. And now this is odd, this is even. It also turned out to be 0 according to this. Even and odd comes out to be odd. And now this is odd according to resumption. This is also odd. Odd and odd comes out to be even. That's why you have to only find out the value of what? Bn. Is it okay? So now let us take an example. You have to find out the Fourier series expansion for this. Now see, let us check whether it is an odd function or an even. If you take minus of f of minus x, then you have to substitute minus x instead of x, which is minus of fx. That's why as f of minus x is equals to minus fx, that's why this function is odd. So for odd, you have to only find out the value of bn. So let us find it. Your bn is 1 by pi 0, just apply this formula ultimately. 2 by pi 0 to pi fx sin nx dx. Okay, so 2 by pi, your fx is x by 2. Let us bring up this out, 1 by 2, and your sin nx is left here. Okay, now apply parts. What do you have to do? 2 is cancelled with 2, 1 by pi. First function as it is, integration of second. The integration of sine is minus cos, and divide it with the derivative of this, nx. Nx means n. You have to write it as n, okay? Because the derivative of nx is n according to x with respect to x. So you have to divide it with n. Then minus formula, minus is in formula. Derivative of x is 1. And now the integration of this, the same thing. Cos is, minus is here already. Cos, the integration for cos is sine. And again, the derivative of this, you have to divide with it. So n is already here. So n square becomes. And the limit, you have to apply for 0 to pi. Now, as you see, if you put pi, n pi, sine of n pi becomes 0. If you put 0, sine of 0 is also 0. So there is no need to consider it. Now take the notation of this. X is pi minus cos n pi by n. Okay. Now if you substitute the values, pi is cancelled with pi. Minus of cos n pi is minus 1 raised to pi n by n. Okay. Now what you have to do, you have to just substitute this into the Euler's formula, which is your fx is equals to a naught by 2 plus sigma n 0 to infinity an cos nx plus bn sin nx. As your a naught is 0, your an is 0, so you have to only find out the value of sigma n 0 to infinity Bn of sin nx. Now listen, if you substitute n as 0 here, it will not define. That's why you have to take the value from 1. N is equals to 1 to infinity. Alright? Now substitute your fx is x by 2. It will become, if you substitute 1, minus 1 by 1. If you substitute 2, minus 1 by 2, minus 1 by 3, and so on. Okay? If the further question asks you that you have to prove something, your fx with something, then you can substitute the value of x as pi or 0, upper limit and lower limit, and you will find out the value. Okay? So in this way we can solve our odd and even function. If you have given with an even function, then you have to only calculate a0 and an and just substitute these values into the Euler's formula. I hope you understand. Rest of the topic we'll discuss in our next class. Till then, don't forget to subscribe my channel. Thank you.